All right, thank you for the awesome introduction there, Patrick. I will not forget that. And so hope you all enjoyed your break. So for the next 30 minutes, we're going to be talking about apps, the awesome world of apps and all the moving pieces that go into making one work. So at a high level, here's the thing. Before we write a single line of code, before we do anything, choose what framework we want to use, what library we want to take a dependency on, we have to make a decision. What kind of an app do we want to build? Do we want to build a web app? Do we want to build a native app? And all of that. So to kind of ease you into this conversation, you guys just got back from break. So let's look at the high level. What are some of the advantages of web apps? And also look at what are some of the advantages of native apps as well. And then we'll take it from there. So first of all, we're going to talk about native apps. They're web apps, sorry. You're all web developers, I'm assuming, so you're probably very well familiar with all of this stuff. So here's the thing. There's a marquee, headline, big font feature, I want to talk about it, is that web apps are ubiquitous. They run everywhere. It doesn't matter what kind of a device you have these days. It has a screen, and more than likely, it has a browser as well. I was at Home Depot last week, and there was a refrigerator, had a big screen, had a browser in it. Interesting time we live in. And so it doesn't matter if it's a small device like a watch, a big device like a television, or even some of the new emerging technologies like VR, AR, and MR. They all have a browser, and your web app will more than likely run on it, probably run very well on it as well. And the other thing is this. Not only do web apps run everywhere, the way you build for them is actually pretty cool. You write one code base based on web technologies, HTML, CSS, and JavaScript. You don't write an app for every device. You just have one code base, and it works really well. And all the stuff you might have spent years learning, your favorite libraries, your favorite frameworks, build tools, IDEs, and all of that, they work beautifully as well. So the web has one thing that's really cool is that it's one code base to rule them all. Not too many languages can really claim fame for that one. So web is cool. We already know that, right? But let's talk about native apps as well. A lot of us build native apps, and there's some advantages they bring to the table also. And if I had to summarize what the big thing about native apps is this. They provide better device integration. They allow you to build apps that really look and feel as if they belong on a particular device. And we look at some categories of what that means. For example, if you have a device that has all kinds of cool communication APIs and sensors, a native app is going to be great for that. Or if you want to squeeze every ounce of performance from your graphics hardware, it's much easier to do that with a native application than an application built on other technologies. And likewise, authentication, it's always a pet peeve of mine. For the longest time, we type a username and password, and if you have two-factor authentication enabled, you then have to go to your phone and prove one more time that it is, in fact, you. But the way I like to sign in these days is on my Mac, I use my finger, I use Touch ID. On my Windows device, I just stare at the camera, and it signs me in automatically, recognizes my face. These are really nice niceties that are really great in native situations. But the device integration isn't just about accessing hardware and sensors and so on. It's also about UI controls. It's about having your app look and feel as if it belongs on whatever platform you're currently on. So my favorite example is calendar. I use the Outlook calendar all the time. And whenever I'm using a third-party app, I like it when the calendar comes up because, one, it looks familiar. And second of all, it's not an empty slate. It contains all my appointments, all my events, so I can actually make a more meaningful decision about what I'm working on. And these are some of the things that native apps are really, really great at. So here's the thing. We're web developers, right? And one of the big things is, how do I take my existing knowledge, all of the things I love to do, and how do I choose which to build for? Web apps have a lot of things going for them. Native apps have a lot of things going for them as well. And so there are two things I like to always, they're kind of intertwined, I like to say. First is, focus on great UX. It doesn't really matter, what kind of challenges that we have as developers to build the app. Focus on great UX. And the reason is this. As users, we care about web technologies, we care about how the app is built, and we can argue endlessly about the most minute details about how an app is built. But the people who are building it for them, they just want an app that's fast. They want it to look good. They want it to be performant, secure, all these things. They don't really care about the underlying technology. And so really, the question is this, what the thesis of our talk going to be is it possible to reach everyone with a web app? Is it possible to maximize code reuse? And lastly, is it possible to provide a great native user experience across all these devices? And as you can guess, the answer is yes, absolutely. It is absolutely possible to make all this happen. And so the way I like to phrase it is this. It's not a web versus native kind of a conversation. It's not two colors on opposite ends of a spectrum. It's actually more of a cooperative environment. It's more of a web and native. And hopefully by the time we get towards the end of it, you'll see that it's actually more of a case where this attraction is something stronger than that. It could be web loves native. And so that's really the goal of what we're going to get out of in the next 25 minutes. So there are 2 steps here, only 2. First one is this: build an awesome web app. That's the first step. And once you've done that, take your existing web app and turn it into native. And we're going to look at what both of those things mean in much greater detail. So what does it mean to build an awesome web app? So in my world, when I say awesome web app, I think of them as actually as progressive web app. So quick show of hands, how many of you here have heard of progressive web apps before? All right, which is fantastic because I know a lot of us have heard about progressive web apps. I've seen talks from Google, Mozilla, Samsung, and a lot of the great companies who've been working really hard on making this a reality. So I'm not going to rehash all of the little minute details of what they are. Instead, I'm just going to focus on the high-level details and then dive in on a few things which I think is kind of cool and unique for us to look at. So at a high level, they're just web apps. If you built any web content in the last 20 years, there's a very good chance you're already a progressive web app or you're very, very close to being one. So that's a nice thing. Nothing new for you to learn, nothing new for you to basically reinvent. And the thing I want to index on, though, is that they're web apps, but they're web apps that provide a great user experience. And user experience, great user experience, those are buzzwords. We hear them all the time. So let's dive in a little bit on what exactly that means. So I have like 8 items I'd like to categorize great user experience by. First one is this. Great user experience is performance. These are apps that start and run really, really fast. And there are multiple measures you can use for deciding what makes an app really fast. One thing I really like is what Google does. They have a really nice set of documentation on how do you go from you wanting to do something and seeing some pixels on the screen that are actually meaningful, that actually allow you to do something. So that's one measure. How quickly can you actually launch your app, see it, and start using it? Second, these are apps that are adaptive, responsive, things that we've been thinking about for quite some time. So I saw this slide earlier where you saw the variety of devices you can build your app on. A progressive web app works really beautifully across all of them, smallest device, largest device, or even devices that don't really have much UI. But beyond just the UI, one of the unique characteristics of apps that run on a variety of devices is how you actually use them. Because the way you use some of these apps, we think of mouse, keyboard, and touch probably almost on an equal footing. That's how we want to optimize our apps for. But nowadays, your apps are a little bit more interesting. You might use a gamepad to interact with it. I have an Android TV at home, and for that I use a remote. And at first, I was like, how can I use a remote to be productive? But it turns out it's actually really well done. The app developers have done a really nice job optimizing a lot of the actions to work with just the simple commands the remote is capable of doing. Mixed reality, whole new bag of tricks on how to do it. So let me think about that. And of course, a lot of us have some sort of a voice-activated assistant that, we talk to it. It usually does something that we want to do. So great. So voice is one of those input devices to think about as well. But so that's one of the big features of PWAs. They're secure. You just saw Nathan's talk a few moments ago, so I'm not going to talk any more about it. It's great. So the next one. These are apps that work offline, reliably, and under poor network conditions. Now here we're getting to something that the web really couldn't do very well back in the day. You had solutions for providing offline, but they weren't great. But with PWAs, you have really good material for it, and you'll see some talks later on the day that touch upon it further. So what this means is really this. You're browsing a website. You will no longer see either the running dinosaur or the broken heart that kind of tells you, my internet connection isn't working, I can't access my content. Instead, you'll actually see the content just as you would if you had an active internet connection, provided you configured your content appropriately, which is very simple. They can view and send push notifications. Now, this is a big one because we've had notifications or some form of notifications for quite some time. But this is the case where my app is no longer running. I'm no longer in the browser. I'm actually doing something else. And let me click to the next slide. And the nice thing is, if a notification happens, I still see it. Even though I'm not on the page, I'm not in the browser anymore, which is really, really useful. And the last thing is this. It allows you to provide better device integration. And this is an area I want to spend a little bit more time on because one of the areas that we've always talked about is that there's this separation. The browser does certain things. The apps on your device do certain things. There wasn't much of an overlap. With PWAs, we're trying to blur the lines a little bit in a lot of these areas. So let's look at what this is. So first, let's look at Android. They have done a really good job trying to integrate the browsing experience with what your device will actually do. So let's say you're in the browser, and you visit a PWA. When you do that, you'll see the Add to Home Screen icon, which will allow you to add the app to home screen, and be able to see an icon that you can then launch and see the app just as you was. You pick up from where you left off, you get an app-like experience, look at the UI, no browser Chrome, no shell, no additional information, but you get integration with, let's say, your settings UI and various parts of that. So I'm having some clicker problems here. All right, so your app will still work in the browser. It just might do more when installed, so you get a really nice experience that is both web-based and outside of the web as well. But on Windows, we've done a lot of work as well over the past few years on making PWAs really a native part of your experience. Charles gave an overview of that during the keynote a few moments ago. So PWA in Windows will just be a native app, also known as a Universal Windows Platform app if you've been following some of the articles we've been writing, and all the advantages that being a native app really provides. And what this means is this. I can go to the App Store. I can find an app that I want. I can install it. And when I install the app, you can see the various integration points. I can launch it. I can pin to start. And I can also just have the app run. And the nice thing is, because it's an app based on web technologies, it's exactly what you see in the browser in many ways. You get all the benefits of it being adaptive, responsive, the layout is fluid, all the cool things that happen. But because it is a native app, though, you kind of get the advantage of being able to have it run on all the variety of devices that Windows apps run on, like HoloLens and mixed reality devices, and all the variety of things that we tend to focus on. So, and also you might have seen a lot of press from the Surface hardware, where the operating system really only allows you to install apps from the store. So your PWA in Windows is actually a great way for you to reach the entire market, so kind of neat. So speaking of the store, there are two ways your app can get into it. First way is the one we've always known. You can submit it manually. You provide the URL, we'll get it in there, great. Second approach is that we submit it automatically on your behalf with very little effort from you, hopefully no effort from you in the future. And the way it works is this. All of you know about the web application manifest. It's one of the components you need to have a PWA. And I like to call this meta text 2.0. We've always specified title, keyword, description, all these things for like decades. This is the next version of it. You provide a JSON file that you link to your page that provides you your app title, icons, splash screen icons, things that your browser might not use directly, but when it's launched from, let's say, the store or from your desktop, you might use this information for something more meaningful. And so what we do is we use Bing. We crawl the billions and billions of documents out there, find these manifest files, and then we find them and turn them into apps. We put them into the store. And the way we're doing this is that we're not just finding every app. We're not putting every app in the store. We're actually focusing on user experience, focusing on quality. And we've done a lot of work to try to figure out what the right balance is. And we're still a work in progress. So we're still piloting this experience. It's a lot of work. And we're getting close to it. But you'll start to see a few apps coming in the next couple of months. And then we'll start to ramp up this feature with more and more functionality based on your feedback, actually. So the thing is this. PWAs are great for developers. I can keep consistent my web code. I like HTML, I like CSS, I like JavaScript, I like my favorite libraries, and I can take advantage of that. But more importantly, it's also great for users, because as a user, I spend a lot of time in the browser, and now I get an experience that is really nice. It's fast, it's secure. I don't have to worry about whether my app is actually a good quality app or not. As a PWA, there's a certain kind of a badge of honor you get that makes your app really, really performant. So given all of that, for many of you, a PWA might be all that you need. You might just want to have a web app. You might want to have the ability to work offline, have push notifications, and then have limited access to the device where you have a start menu button. And that is great. If that is all, then a PWA is fantastic. But for a lot of us, though, we often have to try to do more. We want to be able to get more device integration, get more functionality out of the operating system, for example. And in those cases, we want to take our existing web app native. And there's a subtitle I want to add, though. It is not going to be by building an entirely new app. It's not going to be by re-implementing everything from scratch. It's actually going to be by extending and building on the PWA we've already built. So the goal really is to maintain the goal of code reuse and all the assets you might have already built. So what it means is this. When I think of devices, I think of 4 device categories. You have your iOS devices, you have your Android devices, you have your Windows devices, and you have your macOS devices. That's really where a lot of you probably see most of your traffic coming from as well. So let's say we have a native app running on them. And the content of your native app is not going to be things you re-implement. It'll be content that's largely coming from the progressive web app that you already served from the server. So what this means is that you have a region of your app that's designated for only one purpose, to display the content you already have built already. And there's a name for this. It's called WebView. So how many of you here are familiar with web views? All right, so the next slide is really meant for those of you who raised your hands. If you are familiar with web views, these aren't the web views you might have been familiar with in the past. There's always been a historical view of web views being slow, being just clunky in many ways. The nice thing is, web views have gotten much, much better across the board, across a variety of devices. So if you dismissed web views in the past, highly encourage you to revisit it again. And the other thing is this. The solution I'm talking about here doesn't involve you installing a set of new IDEs, learning a native language to use a web view and all that. It's like you don't have to deal with web views directly if you don't want to, because there's this rich ecosystem of frameworks and tools that have been built over the years that make building apps that take advantage of web view extremely, extremely simple. So I'm going to just quickly run through what these solutions would look like for each of the platforms we looked at. So for iOS and Android, we have Apache Cordova. I know I saw a few Apache Cordova developers here, so if you might also use it in the form of Ionic Framework or even Adobe PhoneGap. When we talk about WebView, this is like one of the ultimate solutions out there, where you're literally having a WebView that works across all your mobile devices, and then uses concept of JavaScript plugins to access native device capabilities. So you're always staying within your comfort zone of web technologies, which is always fantastic. And then for Windows 7, Windows 8, and Mac OS, which we tend to call the traditional desktop, you have Electron. Electron allows you to continue to use your web code for all of the things that you do, and use the large ecosystem of Node plugins to provide the native device capabilities that you might not want to write before. But the important part, again, is you're staying in web code, so pretty good. Life's good. And now we get to Windows 10. So with Windows 10, we kind of took a step back and said, the web is important, native is important as well. Instead of trying to find a solution that kind of tacks on to our existing platform, let's kind of re-implement a platform from the ground up. Let's think about what it's going to take to build an app that's going to be built on web technologies and be native at the same time. And that's exactly what we did. So in the Windows 10 world, a progressive web app you build is going to be exactly the same as an app you want natively as well, which is actually really fantastic, which means that if you don't do any extra work, your app will just automatically work as a Windows 10 app. But the nice thing is when you are in the app container, you can actually do extra work. You just write in your JavaScript, just check for the existence of a Windows object. No third-party library needed, no extra framework that you need to reference. You just check for the Windows object, and if it exists, you can do a lot of cool things. So for example, here's an example of me calling the Cortana APIs. If I'm in a browser, this code just fails gracefully, but if I'm on a Windows device, I can actually use some of the voice capabilities that Cortana provides, which is actually really, really cool. And so what this means is this. The approach we have right now of being able to build an app, have it all be surfaced through your native application, means that I can reuse a lot of my web code. The only additional code I might be adding is just a small amount of JavaScript needed to access these device capabilities that we talked about earlier. But let's go one step further, though. For a lot of cases that you all are dealing with, you might have additional requirements. Web code will take you far, but you might also have native components. You might have a library built 20 years ago in C++ or C#, things that you might want to reference as well. All the solutions I talked about right now give you a way to be able to reference some of these native components. So you have a hybrid solution. You have a mixture of web code, then you have a small amount of code that you wrote to interface with some of the custom code that your team might have built over the years, which is actually a very flexible solution, one that you'll see talked about really, really shortly. So the important part is, what we're talking about right here is not theoretical. It's not something that we decided over lunch a few months ago to say, yeah, it would be a great idea to build an app like this. We actually have been piloting this approach across many apps across Microsoft, some really big ones. And we're going to, in a few moments, have one of the biggest ones out there, which is Microsoft Teams. So I'd like to invite Chandra to talk more about that.
Thank you, Krupa. The slide that shows web loves native is by far the best slide for me. So hi, my name is Chandra Chivikula, and I lead the desktop clients engineering team at Microsoft Teams. I'm really excited to be here to share our development experience for building the Teams desktop clients. So first, a show of hands. How many of you have heard of Microsoft Teams, have seen it, or used it? That's awesome. It's roughly about a third of people here. That's great. So here's a screenshot for people who have not seen Teams before. It's an awesome app for communicating and collaborating. And by collaborating, I mean it's collaboration between one-on-one, between two people, one-on-one, or one to few, or one-to-many, or many-to-many, as in a team. So it was explicitly built to change and improve the way we collaborate, teams collaborate across the world. And so far, email has been a very pervasive form of communication. But at work, things have changed, evolved a lot. So we're no longer emailing documents back and forth. We're no longer sending a message, I'm here, would you come by so we can review something? We're actually changing. There are now newer modes of communication. There are newer ways to communicate which are faster, richer, more instant, and real-time. So at Teams, we allow you to have real-time threaded conversations. Think about using chat as your transport mechanism so that you and your teams can interact at real time about a conversation, about a topic. Then there's also the newer modes of communication, which is live audio and video conference calls. It's not just one people or two people talking to each other. It's actually multiple people, a multi-party video conference. That could be people in the same floor, different country, different continent, different time zones. And there's also, as a team, we work on files. We work on shared objects. We're there to accomplish something. And as part of accomplishing or driving those results, we want to view, share, edit, and collaborate on documents. And not just that. We want to be able to do all of that while we are multi-party video conferencing and real-time chatting. And we also recognize that across the world, organizations are using many popular services and tools for building their solutions for their customers. So we recognize that, and in Teams, we have built extensive integrations to help you integrate these services into your teamwork. There are many other features of Microsoft Teams I'd like to go through. I'll be upstairs after this session, so feel free to drop by to have a chat. So besides showing off some of the cool features, the foundational features of Microsoft Teams, hopefully I've given you a gist of what Teams is. It's an enterprise app that allows people to collaborate. So it's not an app that you kind of fire up and say, I'm going to use it for 5 minutes and quit it. Like, it's an app that stays in your system tray, that allows you to communicate, allows you to read instant messages or collaborate using audio and video calls. So it's kind of a pretty rich, highly, with a lot of breadth and a lot of depth. There's one more reason I wanted to set this context. It is, all of what you have seen about Teams is built using web technologies. I'll let that sink in for a minute. An enterprise app like Microsoft Teams was built ground up using web technologies. To set context again, we have got about 350,000 lines of TypeScript code, about 260,000 lines of HTML, and 46,000 lines of SAS, just to name a few of the top technologies. And it grows every day. We've got many developers working and building and improving Teams. We're using Angular, we're using TypeScript, Webpack, and many, many, many more modern web technologies. It goes without saying that we use open source software, and it's more than 200 different open source components in use. And a key goal for us was to have an extensive single code base that is shared across the web experience in a web browser and native experiences that go across Windows and Mac. We use Electron framework for that. And of course, we want to also target Windows 10. So the first question I get is, why did you guys start off building Teams on an enterprise app using web? There are many reasons. Just a few to name, right, is we're driven at Microsoft and at Teams. We're driven to go to where customers are. And across enterprises and consumer space, most of the people use a browser on a daily basis. So it's a very ubiquitous mode of app. And we wanted to reach the most number of users. That's the first reason. The second, at Teams, we ship multiple times a day and many, many, many times a week, which means we take an idea, we iterate on the implementation till we get it just right. We do internal testings, we roll it out to internal rings, as you have seen, as you've heard about Edge and Windows having insider rings, we have our rings. We do deep validation before we send code out to millions of users. Here's an example. Use a dark theme or light theme? What's the optimal gutter, the width between messages, which allows users to scan and read messages really easily? And third, but not the least, is web is the fastest growing skill set in the industry nowadays. We wanted to tap the resource, especially in our own organization and in the industry, And so, which is why my team is made of awesome web developers. So we started out building a web app. We just don't want to build only a web app. We built the web app with architecturally ground up so that we can ship to web and also build on it for native extensions. Think about if you're running Windows and Mac, each of these platforms has their own platform capabilities. We wanted to utilize that. So in addition to some of the features that Kirupa talked about how web loves native, here is a 30,000-foot view so that we can get the clouds in there of how Teams application is delivered. We've got a Teams desktop apps that is delivered through cloud as a service that pulls down to the client web code, which utilizes the native code that is already present on the client in order to provide a rich, seamless experience. So the rich collaboration, live audio and video chat that comes using native technologies, and real-time communication that comes from the cloud. So talking about native technologies and utilizing your existing native code, anytime you're able to reuse code, it's a win. Anytime you're able to reuse proven best-of-the-breed solutions in your own organization is a win all in all. So at Microsoft, we have a Skype team which has, over the many years, built really impressive, really high-performance live audio and video conference call capabilities using media components, and which also allow for video calling and screen sharing and many more. So we wanted to tap into that media component, this native media components on Windows and Mac, and integrate with our product. We didn't want to reinvent the wheel. So next also comes authentication. I know Kirupa mentioned that he doesn't want to log in every time he goes to launches a different app. So we want to take the base experience of authentication available for the web users, so it's no different from logging into any other website. But if you're on certain native devices which have extra capabilities, we want to use them. So on Windows, if you're domain joined, you boot up Teams, and it logs you in automatically using your Windows credentials. In fact, if you have Windows Hello, you don't even have to type your phone authentication or PIN or anything. It's that seamless, and that's one of the features that our customers really love. So we wanted to provide a great web experience, but we've also wanted to take the great web experience and make it even better for native devices. And of course, to make things real interesting, we want to do this with single code base. I know 350,000 lines of TypeScript, yeah. So here's another view of our code-based distribution at Microsoft Teams. As you can see, the whole of the blue stack there is web technologies. It's using TypeScript, HTML, CSS, SAS, all that. And that's pretty much our bulk of our application logic. All of the core infrastructure is built using HTML and JavaScript and TypeScript, of course. But on certain platforms in Windows and Mac, for example, we use the Electron framework to allow us to extend deep into the OS. For example, for authentication, like I said, we wanted to seamlessly sign you in. On Windows and Mac, we wanted to give you buttered smooth audio and video calls. And I'm really excited to share with you today that we're working on bringing the Teams experience to Windows 10 as a progressive web app. Our vision for the progressive web apps version of Teams on Windows 10 allows us to take the existing huge collateral of web code we have developed and simply target it certain specific areas where you want to light up certain Windows 10 features for Windows 10. And I'll give you a brief overview of how we do that without tripping over the wires. So now that we have established that it is a reality, and there's an app called Microsoft Teams that is shipping single code base across multiple platforms. The question is, how do you make it scale? How do we make it scale? How do you make it scale? So that it's not, spaghetti code, if this, then do this, something else, right? This works, but not very scalable. So there are many strategies. We've chosen one. And our strategy was to organize code by file names and functionality. So let's take notifications for an example. Notifications are, if you're using Teams, you get somebody chatting with you, somebody sends you a message, you see a blurb showing up, and you click and say reply, I'll be there or whatever. And you get an incoming call, that's also a notification. So there are many different types of notifications. These are just two examples. The core application logic for how a client should connect to a service, your cloud infrastructure, poll for messages using long poll, WebSockets, whatever technologies you use, all of that is common. We have chosen to make sure that the core infrastructure is agnostic of platform. And on web, we just show a div or maybe a canvas element to show you a blurb of somebody sending you a message. On the Electron native applications, we use node modules to tap into OS so that you can see the window show up in different corners of the screen so that users can customize it to their needs. And by extension on Windows 10, we bundle notification service.ts, which contains the core application logic for notifications, and layer in notification service.hwa.ts, which contains the add-on code to use WinRT APIs and WinRT components so that you get an OS toast that plugs in seamlessly into the Action Center. This is the one place where we feel this approach has scaled out to many other components. Think about authentication. There's a base authentication service for web. Then we add on ADAL, Azure Active Directory library, for you to seamlessly sign on into Windows. Same thing on the Mac. Next. All right, so this is to round it up, here is a screenshot of our build system. Whenever a developer checks in code, we run CI builds, the continuous integration builds, that builds the code, tests it internally, deploys it to internal rings so that we do deeper validation. Okay. All right, so in a nutshell, to wrap it all up, my name is Chandra. I'll be here upstairs after the session if you want to chat about how we do things. I'm also curious how you are building your own components, so hit me up. I'll be on Twitter and LinkedIn at these coordinates, and we're also hiring. So let's turn it back over to Kurupa.
All right, thank you, Chandra, for the great overview of how an app like Teams can take advantage of both a PWA web technologies as well as have really great integration in a native environment. So we're almost done here. Just want to wrap things up by just quickly talking about timelines on where we are. So we talked about PWAs, and let's talk about where exactly we are with you being able to use them right now. So you can test PWAs in Edge today using the enabled service worker under About Flags. It looks something like this. So once you've enabled it, you can now, in the browser, be able to see notifications, get offline, do all the cool things that a PWA is able to do. And for apps, the next thing is, in the next build, next release, after Fall Careers Update, we'll be turning this functionality on by default in Edge 16. So you're very, very close to having it work without any About Flags modifications. So for apps, we can also get the same thing. We don't support About Flags, but we create another alternate mechanism that you can use instead. You can test your PWA with a special entry defined in the manifest. And it looks kind of like this. You specified this already for specifying the URLs you want to navigate to and permissions you want to provide. Just add service worker equals true, and your app will be able to take advantage of all the service worker functionality and PWA functionality that you want. But it does allow you to experiment with pre-release features. But because it's pre-release and experimental, and we want the store to be an environment where people aren't seeing beta content, you won't be allowed to submit to the store. So it's great for development and testing, but just not for store submissions. And so full PWA functionality, though, on Windows 10 is expected in our upcoming release next year. So time flies, as you all know. So, and of course, Ali's talk in a few minutes will go into much greater detail about some of our service worker plans, so you want to stay tuned for that. And so with that, to tie everything back together, we start off with 3 questions. Is it possible to build a web app, maximize code reuse, and still provide a great experience across devices? And as we've seen, and as Chandra has so ably demonstrated, it is absolutely possible. The 2 things you need to do is just build a progressive web app, build the best possible app to reach the largest audience, and then use any of the solutions we looked at for being able to layer on additional functionality. And once you've done that, you and your developers will be happy because you still get to maintain one code base and stay in technologies that you love to use. And of course, your users will be happy as well, which is really all that matters in the end of the day. And so my name is Krupa, and then both Chandra and I will be upstairs to talk your ears off about PWAs, apps, and all the other good stuff that's going on. Right. Thank you.